This is Aditya Mishra, and today I'm gonna start a new topic in our data structures and algorithms. The new topic name is tree data structure, and I'm starting from tree data structure because according to the college, we should go on. Okay, so before getting into the topic, I would like to say that I will be covering the topic in two manners. First, uh, I will do parallel things, just like I will be teaching data structures, three data structures, and along with that, I will be telling you the time complexity and space complexity, just the part of an asymptotic notations. Okay, so I'll covering both the topic asymptotic notations as well as tree data structures. So, so let's start with the tree data structure. So the first thing that uh, we can consider that why to study tree data structure, because all previous data structures store memory stores data in sequential manner. अगर हम बोले तो पहले जितने भी हमारे पास डेटा स्ट्रक्चर थे, एरे, लिंक लिस्ट और भी क्यू स्टैक्स, ये सब जितने भी थे हमारे पास, वो भी तो डेटा स्टोर ही करते थे। ट्री डेटा स्ट्रक्चर में ऐसा क्या है जिसकी हमें जरूरत पड़ी? तो प्रीवियस जितने भी टाइप के डेटा थे ना, डेटा स्ट्रक्चर, वो क्या करते थे, एक सिक्वेंशियल मैनर में डेटा को स्टोर करते थे। ओके, जैसे एरे या लिंक लिस्ट की अगर बात करें तो कुछ ऐसे डेटा स्टोर होते थे उसमें। ये रहता था हमारा इन्फो पार्ट, और इसमें एड्रेस पार्ट बोल सकते हैं। ओके, तो ये है इन्फो और ये है एड्रेस या लिंक बोल सकते हैं, और ये एक दूसरे से कनेक्टेड रहते थे। लेकिन अब क्या है ना, अब ट्री ट्री का मतलब क्या होता है? ट्री मतलब हर एक चीज एक दूसरे से कनेक्टेड रहेगी। ओके, लाइक ट्री इज लाइक दिस, एवरीथिंग इज कनेक्टेड विथ ईच अदर। सो मेनली दो ही एडवांटेजेस हैं ट्री डेटा स्ट्रक्चर के, जो पहले डेटा स्ट्रक्चर में हम नहीं पढ़ते थे। तो फर्स्ट थिंग ये है हमारे पास, फर्स्ट ये चीज है हमारे पास कि सिक्वेंशियल मैनर में स्टोर होते थे पहले, अब रैंडमली स्टोर हो सकते हैं, मतलब एक हायरार्की भी शो हो सकते हैं। फर्स्ट, हायरार्कियल मैनर में स्टोर हो सकते हैं। हायरार्की मतलब क्या होता है? जैसे हमारे ग्रैंडफादर से हमारे फादर, फिर हम, तो ये हुआ हायरार्कियल मैनर। तो पहले क्या है, हम रिलेशन नहीं शो कर पाते थे डिफरेंट चीजों में, अब क्या कर सकते हैं हम, वो शो कर सकते हैं हम। ठीक है, तो पहला चीज, हायरार्कियल मैनर में शो करने के लिए हम ट्री डेटा स्ट्रक्चर का यूज लेते हैं। सेकंड, जो इसका मेन पॉइंट है कि पहले सिक्वेंशियल मैनर में होता था, अब वो सिक्वेंशियल मैनर में ना होके किसी भी रैंडम चीज को हम रिलेट कर सकते हैं। ओके, फॉर एग्जांपल हमारे पास कोई ऑर्गेनाइजेशन है, लेट मी शो यू। जैसे फॉर एग्जांपल ये कोई कंपनी है, ये कोई कंपनी है हमारे पास, एबीसी नाम है जिसका। ओके, एबीसी कंपनी है। अब क्या है, इसके अंदर सबसे पहले ये ऑनर आएगा, ऑनर यहाँ बैठा है। फिर इसके नीचे आएगा हमारा सीईओ। ओके, फिर इसके नीचे आएगा मैनेजर, मैनेजर। फिर डिफरेंट एम्प्लॉयज, डिफरेंट डिपार्टमेंट्स के डिफरेंट एम्प्लॉयज आ सकते हैं। ठीक है, अब हमारे कॉलेज का ही देख लो, किसी भी कॉलेज का तो सबसे ऊपर रहता है ऑनर, फिर सीईओ, फिर प्रिंसिपल, फिर एचओडी, फिर डिपार्टमेंट के, डिफरेंट डिपार्टमेंट के एचओडी, फिर एम्प्लॉय जैसे टीचर्स। तो ये एक ऑर्गेनाइजेशन का ही हमारा एक हायरार्कियल वे में एक रिलेशन है। तो सिंपल देखे तो ये सिर्फ ट्री को ही रिप्रेजेंट कर रहा है। ओके, मतलब एक लाइन से एक रिलेशन शो कर रहा है सारे में। तो मेन दो चीज मैं बताया कि फर्स्ट थिंग तो हायरार्कियल मैनर हो गया, और दूसरी चीज ये है, दूसरी चीज सिक्वेंशियल मैनर में नहीं होता है। कैन रिलेट, वी कैन रिलेट रिलेशंस, वी कैन रिलेट रिलेशंस इन एवरीथिंग मतलब हम किसी भी डिफरेंट चीज में differently. So I was telling that the two things about the tree data structure. First is the we can show a relationship in a hierarchical manner, and second thing we can relate relationship between different objects. Means we can relate things differentially. Okay, so these are the basic things that we mainly focused on the tree data structure that make it different from the other data structures. Okay, now how we can represent a tree data structure? As we can already see that representation, it's mainly represented as this. It's very easy. Okay, so this is a basic representation of tree data structure in which this is known as a root node. It's known as root node, and these all are called as child of that root node. Child of root node. Okay, so let's discuss one by one things in description. Like the first thing that we have to see is a root node. So here you can see that the root node. What is the root node? The topmost node is called the root node. So here in this picture, if you will see, so this is known as root node. This is known as root node, and with the 10 value is stored. Okay. Thereafter, leaf node. What is leaf node? Node having nothing below them are known as leaf node. So, like in this picture, if we talk about the leaf node, what will be the leaf node? So, this, this, these all the nodes are known as leaf nodes because they don't have anything below it. So, left and right subtree are null. So, these nodes are known as leaf node. Okay. Now, let's see what's the children node. Children node, nodes which are below another node is the children node. Example 8 and 30 and 80 are the children of node 30. Like here, this is the uh, look. This is the parent for this. So here 8 and 30 both act as a child of which root node. Uh, the root node for 8 and 30 is 30. I think it was 30. Okay, it's 32 times, so make it a 3. Okay, so 8 and 30 act as a child of node 3, so it's known as children node. Thereafter, parent node. What do mean by parent node? So as we told that 8 and 30 are the children of node 3, so we can consider 3 as a parent node here. Okay, and children of children of 3, third node. Okay, so it's known as children of third node. Thereafter, we have discussed the basic things: root node, leaf node, children node, and parent node. These are the basic things of a which is used in the representation of tree data structure. Thereafter, moving on to the next thing, tree data structure is recursive in nature. What do we mean by that? Means a tree contains subtrees inside it. They are called subtrees of a tree. Why we call this tree? Why we call this tree as recursive in nature? It's mainly because uh, we can see that. Look, that's a tree and that's a subtree. Like this is the left subtree, this is the right subtree, this is the root node. Okay. So why we call it as a recursive in nature? So we mainly call it because it contains another tree, means left subtree, right subtree, and the parent node. So we can call it as a recursive in nature. So if a question arises that tree data structure is recursive, why? So we directly have to tell that because it also contains subtrees in it, so it's called a recursive in nature. What are descendants in a tree data structure? Descendants of a node. Descendants of a node are all the nodes that lie in a subtree, which this particular node as root. Like here. Now let's take another example. This is a tree. Okay, okay. Take the value. Take the value. Uh, 2, 3, 4, 5, 6, 7, 8. Okay. So uh, after taking the value, let's see the descendants of that node. So what the definition tell us that descendants of a node are all the nodes that lie in a subtree with this particular node as root. Example, in the above figure, descendants of 20 are 40 and 5. Look, here descendants of 20 are 40 and 5 means every node that lies below another node can be called as a descendants. And in the this figure, if we call it as a descendants, so 5 and 6 are the descendants of which node? 3. Okay, got the descendant point. So you can basically see the definition from here from the notes also. So no worries for that. Thereafter, moving on to the degree of a node. What do mean by a degree of a node? Total number of children of a node can be considered as a degree of a node. For example, degree of here we can see the degree of 10 is 2 and 20 is 2 and 30 is 3. Like here. Just a second. Degree of node. Total number of children. Okay. So node 20 has two children, 40 and 5. So its degree is 2. Okay. Here the uh, it 3 contains the three children, 8, 30 and 20. So its degree is 3. Simple. Degree of a node. Thereafter, internal node. What do you mean by internal node? Tree having number 0 degree or which are not leaf are known as internal node. Like what? Like 9. It can be considered as an internal node because it contains a node having value null. It also contains another node in the right subtree having the value null. So we can consider it as an internal tree. Okay, internal node also. Okay, so this is the basic things that we have discussed in tree data structures, and after this we'll be moving to the next topic. Let me show you that the next topic is some part uh, is left behind. So we'll see in the next video. Okay, thank you.